A very good morning, good afternoon, good evening to all the participants and these candidates for this NPTEL MOOC course, the title of which is Application of Forecasting, Regression and Time Series Models. As you know, the three main topics to be covered in this 60 lecture, which is 30-hour course, are as following: averaging techniques and forecasting, which is point 1, point number 2 is regression models, and point number 3 is time series. And we are considering now different examples of averaging techniques and forecasting. This is third week 14th lecture, so which is the second last one for this week. And if you remember the coverage of the last week, we were basically trying to give a example which I was solving in Excel sheet using the concept of adaptive one parameter exponential smoothing. So, coverage here would be the continuation of exponential smoothing single adaptive parameter, and I will go into that problem in details and just discuss about multiple adaptive parameter concept. And then if time permits, let me see, go into other examples of forecasting models. But if the time taken to solve the problem, because I want to go slow step by step for the single adaptive parameter problem takes time, we will consider the multiple adaptive problem and other forecasting problem in the 15th or the 16th lecture as we proceed. Now, if you remember the problem, and with this information I will go back to the Excel sheet. So, generally I told you that the forecasted value for t plus 1 would be based on the fact that we are taking that value from y t. That means, today's actual value would give me the best forecast for tomorrow. Hence, y 1 would be f 2. Also, which I was not there in the slide, but I will basically update it, where the slide in the sense which in the video recording, and I will update that slide when it is shared with you through the NPTEL MOOC office. We are going to consider the starting values of A1 and M1 as 0, and for discussion we will consider alpha 2 as or alpha t as 0.2, which will adapt, and beta will consider as 0.2. So, why we are considering alpha 2? Because it is the time frame based on which we are considering. So, let us go back to the slide, and as required we will switch between the information given and how to solve the problem in the Excel sheet. So, let us go back to the Excel sheet. So, I have copied the data, and I will highlight the concepts as we proceed. Now, we are considering alpha, the first value as 0.2, beta as 0.2, and these I am marking in blue and will keep changing it in order to substantiate one important fact, that what values of alpha and beta should be taken to minimize their error. And error, as you know, in the concept of matrix, they can be different things. It can be mean squared error, it can be mean absolute error, and all these things. So, I will consider the simple ones as that once the one example or two example with the same data set is solved in different ways, considering different metric, considering different parameters, things would definitely be crystal clear to all the participants and the candidates who are taking this course. First fact, so the value of f 2 which is coming in February is equal to y 1 value which is coming from January. Well, it is basically the cell value of B 2 would basically be the cell value of C 3. So, if I can copy from the previous, I generally do not switch back, but in order to save time I am doing it. So, this is the value which will be copied. So, this is for much clear clarity and without any ambiguity. ET is 0, because we are considering the error to be 0, AT-MT 0, 0.2, 0.2. Now, come to the error term. Error term for February is the difference between 135 and 200, which is the difference between cell B 3 and C 3, the value comes out to be 65. Now come to the nomenclature, how we follow and how we do the calculations. So, these are given in this slide which was already shown to you in the last class. So, I will just follow it. So, the first term is basically the error which has been written down in the cell, which is the difference between February's actual value minus February's forecasted value. Hence, the value is coming out to be as minus 65, which is given in cell number D3. The next value we need to find out is AT based on beta into ET plus 1 minus beta into AT minus 1. So, beta I am considering as 0.2. So, beta is basically as a cell H2, which is here, which I am just highlighted, multiplied by say the value of ET. ET is basically 0. So, if you see ET is here, which is the value which you see here, it's there. I will just use the drawing one as the value which is here. So, this is the term beta into ET, I marked in red. So, that is basically the first term, which is H2 into D3. H2 is beta and D3 is ET. Now, if I go back to the ET would be not 0, it will be basically 65. So, 0.2 into minus 65, and the next value if you see, which I will mark in say for example green, is 1 minus beta into AT minus 1. So, 1 minus beta into 1 minus beta is equal to this term 1 minus H2 into AT minus 1 is basically 0. So, the value is basically minus 13. So, when I come to MT, MT is basically exactly the same thing. I will again use the color, say for example pink. So, beta into mod of ET. So, beta into mod of ET is there, beta is basically H2 and mod of ET is 65, which is plus 65 obviously, because you are taking the absolute value. And the next value is 1 minus beta into F2. F2 is basically the value which I will again mark using different colors, say for example orange is basically 1 minus beta into MT minus 1. So, MT minus 1 is 0. So, this is the value, and I need to find out alpha next value, which is mod of, as you can see, I use the dark green one, which is basically mod of AT-MT. So, AT-MT is basically 13 by 13 is 1, and next value is basically is the, then I again proceed, I need to find out the forecast, which is important. Now, what is forecast value? If you see the formula here, let me use the lavender one. So, F t plus 1 is equal to alpha t y t plus 1 minus alpha t f t. So, 135 how do I obtain? Is basically alpha value being 1 into the value of B3, which is y t, 1 minus 1 which is 0 into f t, which is 200. So, I get this value. Now, what I do is that I just, because I have already fixed the value of alpha beta, which is important because that is not changing, I copy this. So, when I copy, I go to the next values. So, this error would be, as you know, is difference between now B4 and C4, which comes out to be plus 60, and the corresponding value AT, MT, alpha t are found out. So, if I follow this formula, copy it, I get these values. So, I will double check the values in the PPT slide and do changes accordingly. Now, if you see here, these are the values of alpha. I will just plot it. So, in order to show that these alpha values are fluctuating. So, if you see the values of alpha are given, if I plot the line, so this is the alpha values how they are changing. Now, I am going to remove this graph because that is not immediately important. What is important is the error. So, let us find out one by one mean absolute error. I will go step by step. Mean squared error. So, mean absolute error would basically be the sum of all the absolute errors divided by the number of readings. So, what is the number of reading? So, it is the first error is 0, no not 0, 65 because we are starting from the first value. Then it is absolute of D4 plus absolute of D5. If you see it is including one by one all the errors, plus absolute value of D6 plus absolute value of D7 plus absolute value of D8 plus absolute value of D9 plus absolute value of D10 plus absolute value of D11 and last was basically absolute value of D12. So, we have calculated, considered, not calculated, considered all the absolute values. I have summed them up. Now, once I sum them up, this is not the mean absolute error. I have to divide by the number of reading. So, if I find out, I need to find out the count of the values. So, the number of count values which are here. So, let me check the count function is working. So, I do not want any error for any one of us to understand. The count value is 10 and as it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, count is 10 which is perfect. So, the mean absolute error for alpha 0.2 and beta 0.2 is this. Now, let us consider the mean squared error. So, mean squared error would basically be the difference between the actual and the forecasted, square it up, add it up, divide by the count. Count means 10. So, if I follow it, again I am going slowly. So, this is first is basically the this values of the errors being squared. So, I can basically find out D3 whole square plus D4 whole square plus D5 whole square plus D6 whole square plus D7 whole square plus D8 whole square. If you see, it is including all the errors one at a time and it is squaring. Then D9 whole square plus D10 10 whole square plus D11 whole square plus D12 whole square. So, this all the squares are done. So, I can just find out the sum of the squares and then I need to find out divide by the count. So, count of number of readings which is basically so it was basically count D3 to D12 which is also count D3 to D12. So, it is 7080 mean square. Now, if I need to find out the the so called standard deviation, means square, this is the square error. If I want to find out the so called standard deviation, even though standard deviation concept has been mentioned, but that has not been repeated by me as the metric, but we will consider that. So, basically I will copy all these values, and basically that would be the square root. So, I find out the square root of this term. So, it is 84.15 and mean absolute error is 76. Now, the interesting part. See, if I'll just zoom out a little bit. So, if we see, if I change these alpha values, say for example, if I make it 0.5 and you immediately see the cell values which are there in D14, D15 and D16 will change. So, they now, wait 1 minute. Wait, just 1 minute. They should be changing, but I have, okay, I need to basically consider this value first. I will keep it 0.2 and this basically change it to 0.5. See, with a value of alpha as 0.2, which is starting value, and a beta of 0.5, if you see, the mean absolute error is now 81 and standard deviation is 90. If I change again as beta as point, say for example 7, immediately you see mean absolute error becomes 74 and standard deviation is 81. Now, the question is, first let me do it alpha, I will write it here. So, I will make a table accordingly. So, beta I make it here. So, I take alpha as 0.2, beta as 0.3. So, for beta 0.3, I will write what is the mean absolute error and one is the standard deviation. So, for 0.3, the value is, I will copy the absolute values, it is the values, and I copy the values. Now, if I change it, so 0.2, 0.3 now becomes 0.5 beta. So, I change 0.5 beta here and the means absolute value is now 81.6694. It was 89.696, now 89.6694, and the value of this is remains same. Last value we will take. So, let me make it a bit more clear. So, the mean absolute error and standard deviation. Now, if I go to 0.2 and 0.7, and I have mean absolute error and standard deviation for 0.7, what are the values? So, it is 74, which has decreased, and this has definitely decreased from 90.64 to 81.73. And finally, let me take another value 0.9. This I am all doing in the case for changing betas, alpha is fixed for the time being. So, for 0.9, the values are 65, it has again decreased. Standard deviation has also decreased. So, for values of alpha beta, I am able to plot it accordingly. So, I will mark it in, say for example, yellow. So, these are the values which I should mark in, say for example, light green. So, for 0.2, this is 0.5, is not 0.2 anymore. This is again 0.2, 0.7, and this is 0.2, 0.9. Now, let me check that how alpha values can be changed, and we can for these changing values of beta also, that combination and been kicked. So, let me check if I missed something, because as we are going slower in solving this problem, as I keep saying it time and again, there should not be any ambiguity in the mind of the students, so that it's crystal clear to all. Now, if I consider the value of the starting value. So, the starting value technically, if it is 0.2 here, let me check. Just for clarity. So, if I make it 0.2 here, if this is, say for example, let me check for 0.3 and 0.2, then if I check it, change it to just one is 0.5. Yes, now I understand. So, I will start with 0.2, and the next value which I am going to take, I am repeating the value of January and February and then updating the alphas. So, my mistake when I took the value for February for the alpha t being the absolute value of 80 and empty, it would be just be the last value and it will keep updating. So, if I 0.2, 0.3, the values of the errors are like this. If it is 0.2, 0.5, the mean absolute error and mean standard deviation is this. When it is 0.7, mean absolute error and the standard deviation is given. I will read it out and I will also plot it. And finally, 0.9 for beta, mean absolute error and the standard deviation is this. Now, I will repeat this for the case of another value of another value of alpha. Beta, I will keep it same. So, these values will be replaced. So, I am replacing these when they come. So, now let me consider as 0.4. So, if it is 0.4, 0.4, 0.4, 0.4 alpha, and I put 0.4 here, and I find out, so 0.4, 0.3, it is 73 for mean absolute error and standard deviation is 82. I am just reading the first two numeric, not the decimal. Decimal would become relevant as I go to the discussion accordingly. For beta 0.5, mean absolute is this 72 and it is 85. So 4.7, mean absolute is 69. Oh, I think I have not copy pasted the number. And finally, done. Now I consider the value of another set of, so consider is 0.6 for alpha, and I will consider again 0.3, 0.5, 0.7, 0.9 for beta. So, let me again write them on in the table. So, for was 0.3, so is 73.0698, there is not much of a change. Oh, this will be 0.6, sorry. So, it's 77 and this is 85. Then if I consider as 0.5, these are the corresponding values which I am copy pasting, numeric values. Finally, 0.7 for beta, numeric values being copy pasted in this table which I am making. And finally, for 0.9, numeric values are being pasted here. Those are the values, not the formulas. Now, let us see some interesting thing. If I check the minimum value for the combination means 0.2, 0.3 of alpha and beta, the mean squared error and standard deviation is this. If I check here, the minimum value which I find out of would be, it is 68, 67, 65, 59. So, for alpha 2, beta 0.3, alpha 0.2, the minimum value is here, which I will mark with, say for example, pink color, minimum. Now, if I want to find out the minimum for standard deviation also, it is coming out to the same thing. So, both mean squared absolute error and standard deviation are minimum for this combination of 0.2, 0.9. I have not considered other values of combination of 0.2 and betas any, but these are the minimum values. If I consider the minimum values corresponding to the case of 0.4 and 0.9, again these are minimum for that values, and if I consider the minimum values, it is this 0.6 and 0.9. But interestingly, if you see, as you keep increasing the value of alpha from 0.2 to 0.4, 0.4 to 0.6, the error values are increasing, which means that I try to keep alpha as low as possible and beta as high as possible. So, because if you see beta values being 0.9 and alpha being 0.2, you are getting the minimum values as shown by the values 59.446 and 71.9534. Now, with due respect, I would like to extend this class by few minutes, and the reason being that it is important for me. If you remember, I had shown you a graph which was about the alpha values. So, I will mark the alpha values accordingly and I will take the values as this. So, I will not delete, but I will mark the values here. So, here what I have is like this: alpha 0.2, beta 0.3. So, if I have, so if I follow this, I have the graph of alpha to beta 0.5, then beta 0.7, and from beta finally beta 9. So, I will do it for all values of alpha is 0.2. Let me again 0.2 alpha and 0.3 for beta. So, I copy all these values for, these are for alpha 0.2 starting. So, I paste it. Then I change it to 0.5. I have these graphs or values. I have not drawn the graph. So, now when I make 0.7, I copy the alpha values. I am only interested in the alpha values. Error concept has already been discussed. And when I make beta as 0.9, now if I draw it, so I basically have the serial number 1. Serial number means, okay, it would basically be the month of January to October. So, let me also make it November. Yes. So, if I plot it, so these are how the values of alphas are fluctuating. So, along the x axis you have the month and along the y axis you have the alpha values, and if you see the blue color is for alpha 0.2 beta 0.3, then red is for alpha 0.2 beta 0.5, similarly the gray one is for alpha 0.2 beta 0.7, and last one the yellow one is for alpha 0.2 beta 0.9. And if you see the amount of fluctuation which you have for the values of beta 0.3, 0.5, 0.7 is high, but not for 0.9, which means the higher the values of beta, and obviously we saw from the error terms, lower the values of alpha will give us the best answer. So, with this I will end a little bit lengthy class, but I will continue discussing this problem with more graphs later on for the single adaptive model. Thank you very much and have a nice day.